next. The ideal gas law looks at ideal gases, and we don't know what that is. So I'm going to define that first, and then we're going to get the math equation from there. But basically what an ideal gas is a gas that follows all of the rules, all of them, for the kinetic molecular theory. Now, we know that things don't really follow all the rules, but when we're looking at an ideal gas, we're going to assume that these ideal gases, they take up space. So they're going to completely fill the shape of their container. There is zero intermolecular forces. And I said that last unit. I said gases have zero intermolecular forces. There's technically a little bit of them, but for the sake of this course, I just say there are zero intermolecular forces in a gas. They're all ideal gases. There's no attraction. So when two gas molecules are zooming past one another, they're not attracted to each other at all whatsoever, and they are constantly in motion. Now you can't break that because we're above 0 Kelvin, so they're constantly in motion all the time. However, when we look at these gases, we're going to treat all gases like ideal gases. Now, again, sometimes there's a little bit of attraction. Sometimes they don't completely fill the shape of their container. Sometimes there's a little bit of intermolecular forces there. But we're going to treat all gases like ideal gases, just like they are following all of the rules of the ideal gas law. Ideal gases, sorry. So now we have the ideal gas law. So our ideal gas law just says that based off of the pressure and the volume, the moles of the gas, and the temperature, gases have very predictable behaviors. Nothing changes in this law. It's just, hey, based off of this pressure, this temperature, this volume, this is how many molecules have to be there. Or based off of this data that we have, I can find the pressure because I know the volume and the moles of the gas and the temperature, because gases are very predictable. The ideal gas law, a lot of times people, like teachers, just call it PIVNERT, PV equals nRT, PIVNERT. So with your ideal gas law, PV is equal to nRT. We have different variables, and it's just going to give you the variables, and you're going to have to solve for them. So pressure is in ATM. The V is volume, that's going to be in liters, just like we had before. And then down here, this T, that's temperature, that has to be in Kelvin. If you don't have those units, you're going to convert it out, so you do. Moles, like Avogadro's number of moles, a lot of times they're going to give you grams, you have to convert it to moles. So if they give you the grams, you have to convert it to moles by using your molar mass. And then we have R down there at the bottom. R is a constant value. We're going to do a lab that we actually derive R tomorrow in class, actually. But that R value, anytime you see the letter R, no matter what, you are going to plug in the value 0.0821 liters times ATM over mole Kelvin. So the R value won't be given to you in the equation. You just need to know, hey, here's that number. Here's what I'm going to plug in for it. So PV is equal to nRT. Pressure is ATM. Volume is liters. Moles is in moles. And then your temperature is in Kelvin. R value, 0.0821. When you have your R value, it has all of those units attached to it because it's a constant value. The reason why it has 4 values is all of them are going to cancel out except for one of them. And that one that's left is the unit that it's going to ask for in the math problem. So we have some sample problems here. I'm going to do the 2 sample problems on my document camera. And then you should be good to go after that for your PIVNERT problems. So we have PV is equal to nRT. This R value is always 0.0821 liters ATM over mole Kelvin. That is on your reference sheet. You don't have to worry about remembering that or anything like that. But the R value is 0.0821 liters times ATM over mole Kelvin. For the PV, N, and T, I'm going to look at my problem here. It says calculate the number of moles. So moles is N. That's what I'm solving for. Of ammonia gas, which is NH3, contained in a 3-liter vessel, liters is volume, at 300 degrees Celsius, it's temperature, with a pressure of 22.05 psi, so there's my pressure, PVNRT. So with this problem, I need to check the units. Pressure has to be in ATM, which I don't have. I'm going to convert this out to ATM. There's 14.7 psi in 1 ATM. So I'm going to get my answer here. 22.05 divided by 14.7. I get 1.5, 1, 2, 3, 4 sig figs for my ATM. Volume has to be in liters, which I have. N is moles, that's what I'm solving for. R is given, and then the T is temperature. Temperature has to be in Kelvin. So I have 300 degrees Celsius, so we're going to take 300 plus 273. You get 573 Kelvin for my temperature there. So now all I need to do is plug in my numbers. So when I plug in my numbers here, I have 1.500 times V is 3. Oh, it's only 2 sig figs. Is equal to N, that's what I'm solving for, R 0.0821 times my T, 573. To get N all by itself, I'm going to divide both sides by R and T. So I moved those over. So now I'm just going to get my calculator. When I get my calculator, I'm going to take 1.5 times 3. Ooh, 1.5 times 3. Let's try that. Oh, goodness. Okay, 1.5 times 3. Let's get that. Divided by, open parentheses, 0.0821 times 573. If any of you guys ever go into engineering and you want something to invent, come see me. We're going to make a calculator that's just for chemistry. We're going to put an R value in there. We're going to put Avogadro's number in there because you're going to get used to that number. You're going to get sick of typing it in all the time. I always wanted a calculator with an R button and Avogadro's number. Anyways, don't worry about that. Side note. So we have sig figs, 4, 2, 3, and 3. So I can only have 2 sig figs in my answer. So we get 0.096. And then moles is my unit. So they might have you stop there where you just have to find your moles. Sometimes the question is going to say calculate the number of grams of ammonia instead. If it asks you for grams or if it gives you grams, you're going to use your conversion factor that 1 mole is equal to the molar mass in grams from the periodic table. So if it asked for grams originally here in the question, if it said calculate the number of grams of ammonia, you would have to get to this step anyways. Once you get to this step, then you're going to take that answer and you're going to do the conversion like we did earlier in this semester, where we're going to put 1 mole on the bottom, and 1 mole is equal to the mass in grams on the periodic table of ammonia, NH3. Nitrogen has a mass of 14.01 grams. I have 3 hydrogen. Each one has a mass of 1.01. So we get a molar mass of 17.04 grams. So I'm just going to multiply these two numbers, 17.04 times 0.096. Originally we had 2 sig figs here, so my answer is going to have 2 sig figs, so we get 1.6 grams. So based off of the predictable nature of the gas, the ammonia here, because we knew the volume and we knew the temperature and we knew the pressure, we were able to calculate the number of moles in the sample by using PVNRT. PV is equal to nRT. Gases are just super predictable things. Now this one, it says determine the temperature. So I'm solving for T. Again, we have PV is equal to nRT, PVNRT, of 2.49 moles, moles is N, of a gas contained in a 1 liter volume container at a pressure of 14.3 kPa. So that's my pressure. R is not given. R is never given. If you need that R value, it's 0.0821 liters times ATM over mole Kelvin. So I have R, I'm solving for T, I have N, V, and P. So in order to do this one, we're going to take P, which I need to convert, 101.3 kPa is equal to 1 atm. 14.3 times 101.3. This has 3 sig figs, so I need, nope, I put times. Man, I'm like really struggling today, sorry. Let's divide. 3 sig figs, so I need 3 sig figs, 0.141 atm. So P, 0.141 times V, 1, is equal to N times R times T. That's what I'm solving for. So PV is equal to nRT. I need to get T all by itself, so I'm going to divide both sides by 2.49 and 0.0821. So now I'm going to plug these into my calculator. When I plug these into my calculator, I'm going to take 0.141 times 1 divided by, open parentheses, 2.49 times 0.0821. 3 sig figs, 3 sig figs, 3 sig figs, 3 sig figs. My calculator is going to give me more than that, so I'm going to round this to only have 3 sig figs. So we get 0.690, because the 7 makes the 89 go up to 90. And then for my units, I am using temperature, so that is Kelvin. So with this, I get 3 sig figs, 0.690 Kelvin. I hope that this helps. If you guys have any questions, definitely ask. Otherwise, have a great day.